Okay, in this particular video, we're going to talk about Bitcoin. Now, first of all, we try to explain what a blockchain is. We said we have different nodes spread across different parts of the world. Nodes are just like computers. And we said each of these nodes has um, blocks or chains of blocks. Chains of blocks, the same copy spread across each node. Now, I need you to know the difference between blockchain and cryptocurrency. Bitcoin is both a blockchain and a cryptocurrency. I'm going to explain. This thing we saw here, the act of chaining, two blocks. A block is a record of transactions sealed with a hash. The act of chaining blocks together. This is what is blockchain. This is what we have as blockchain technology. This is blockchain technology. Now, obviously, this is just a store of transactions. Yeah. What do you use for transaction? You have to use a currency. There has to be a currency that before you can transact, before you can buy and sell things using, you have to use a currency. So now, that is what cryptocurrency is. Cryptocurrency is the currency they spend in blockchain. It is the act of spending this cryptocurrency that they now record in blocks, which they chain together. So that is how those words came about. So Bitcoin is both a blockchain and a cryptocurrency. I'm going to explain. They spend Bitcoin. Bitcoin is a blockchain. Like the name of their the name of these blockchains is Bitcoin, and they also spend Bitcoin. So that is why they named their coin Bitcoin. That is why Bitcoin is both a blockchain and a cryptocurrency. So now back to blockchain. We talked about having different nodes at different parts of the world or maintaining the same copy of the blockchain. Now, if each of them are not seeing themselves physically and at every time anybody can become a node, how do we maintain consistency? Like, how do we make sure that everybody has the same node? Because everybody is adding the blockchain by themselves. So, how do we maintain it? Now, in the previous stuff we talked about, where we talked about the PBFT for the Byzantine's General's problem, we mentioned the solution of voting. But now in the Bitcoin, remember we're talking about Bitcoin. In the Bitcoin ecosystem, they don't vote. They don't actually vote. So to know if all of them are in the same page, they do something different. What they do is proof of work. They use working to be able to know who can validate a transaction. Let me explain. So now let me walk you through the process of how this is being done. Let's say you are this person and you want to make a transaction. Let's say send 3 BTC from my wallet, let's say OX224 to OX444. and you click on send. The moment you do this, the provider, let's say you're using an app or something, this you've initiated a transaction. This transaction will be broadcasted to this transaction you just initiated will be broadcasted to every single node, not every single most of the nodes around. For now, let's just use every node because we are working with a small group of nodes. It will be broadcasted to every single node. As it's broadcasted to every single node, that means everybody sees the transaction. Most people see the transaction. So now let's assume that me now I am the person operating this node. So when I see this transaction, what I am going to do is this. I'm going to check. That's the reason why we have them, these nodes. I'm going to check trade BTC from this person to this person. I will check whether, okay, does this wallet have 3 BTC? Yes, it has 3 BTC. So basically what I'm doing is I'm just checking if this transaction you initiated follows the rules. Obviously, they are financial rules. It follows the rules. So I'm preventing that, what's it called? That double spend problem. So if I check and I see that, okay, yes, it's what's it called? It's true. You follow the rules. I cannot just add it to the blockchain. If I add it to my own chain, nobody knows about it. Everybody will not add it. So what I will do is there's something called a meme pool. So everybody has a meme pool. A meme pool is just like a temporal list of transactions. Let me put it that way. So I'll just put it in my meme pool. Understand? Now every single person has their own meme pool. Everybody has their own meme pool. So this person, now remember what I said, that this transaction sometimes is not broadcasted to everybody. So there can be another Mr. B here that sends his own. That his transaction that initiates another transaction, let's say 4 BTC from OX333 to OX111. This person's what's it called? This person's transaction might be broadcasted to just this thing. Now you can see that in this particular case, this person's transaction will be recorded in this person's main pool, but it's not recorded here. Different nodes have different main pools. So this person's main pool is just like a temporary block. Now you can see that this person's transaction here will be recorded in this tree, whereas this person's transaction is only recorded in these main pools. So you can see that main pool is just a combination of random transactions from different angles. You understand? Now what do they do with these main pools? Since everybody have different main pools, this is the reason why they cannot just carry their main pool. Sorry, I wrote this twice. Let me quickly erase this. Yeah. So everybody has their own main pool. So everybody cannot just add it. If this person adds his own main pool here, this person adds it, it's obviously different because the transaction of this person got into this person's main pool. Transaction of this person got into this person's main pool. So it's not going to be consistent. The ledger has to be consistent. This chain of ledgers has to be consistent. So what do they now do? Instead of voting, or instead of trying to, everybody will send what they have and they will select and blah blah blah, there's something they do. They call it proof of work. So one person has to suggest their main pool, or let me just call it that. It's not technical, but let's call it that. One person has to suggest that, okay, let's use this my mempool. This mempool I've compiled. You will now send it to everybody. Let's use it though. Then if everybody now checks his own and see that, okay, they'll individually verify. This person now proposed that, okay, let's use this my mempool. Let's use this stuff I compiled here and add it to the chain. Everybody will now look into this list of compiled what's it called, list of compiled transactions. They will individually verify it, and if it is correct, everybody adds it to their chain. So now they will have consistency. That is not exactly how it is, but for the sake of understanding. Now you will now ask, who has the right, or which person is going to propose? Since we have a lot of people, who is going to propose this thing? Now that is where proof of work comes in. The person who is going to propose will have to show proof, just like in normal term, you gotta show workings. Now this work is basically you have to solve a math problem. You have to solve a math problem. This math problem, to solve it, you need high energy. By energy, you need machines, you need actual computers, you need computers that consume energy. Because to solve it is not something you do with a pen and paper like you'll be thinking. It's something that you do with large systems, large computing systems, large power. So these people that out of all these nodes, these are nodes, remember, validators or nodes. Out of all these nodes, there are people they call miners. So the miners basically are the ones that get to decide which block is suggested. Which block is suggested. So let's say this person is a miner. For instance, this particular person is a miner. What they will do is this. What this person will do is this. Anybody can be a miner. So how do they not select which particular miner will suggest the block? It's proof of work. All the miners will be in competition with each other. They will have to solve a particular equation or something. It has something to do with blah 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 that is lower than the hash. I don't want to go into that. We're going to get into that later. So they will have to solve. The first person to solve, they will have to compile a block and solve. So the first person to officially compile a block, the block has to meet a requirement. That's the thing I said I don't want to go into. So if this miner is the first person to solve that equation, to be able to compile this block, you have to solve the equation. So they have to solve an equation, compile a block. So the first person to do that, once he's done solving and compiling the block, and the block meets the requirement, he will not just propose his mempool. No, that's why I said the initial thing I was explaining here is just an example. He will take the transactions inside his mempool, compile each of them, and create a new block based on a particular requirement. Now, once he's done creating that block, the first person to solve the math equation and compile that block, he will now broadcast it to everybody that, okay, this is a suggestion. Let's make use of this block, just like I explained earlier. One person makes a suggestion of the block, they will make use of. So now, after making the suggestions, now everybody has a copy of this proposed block by this miner here. Everybody has a copy. So what everybody will do now is they will check it. They will check, okay, since you have transactions written on it, they will individually verify these transactions. Individually verify them. And when they verify them, if what this particular node verifies, if you see that this is true, you will add it to his chain. If this one sees that this is true, you will add it. If this is a false, if this miner is what's it called? I'm coming. Let me before I go into that. How do miners make money? First of all, they get paid if everybody, or or if the majority accepts their block. So if this person validates this block, this person validates this block, it's going to be added to the chain. Basically, everybody will now have, remember that stuff I said, consistency. Everybody will add it. Most people will add it. Once they validate it, they will add it. If this person refuses, he will not add it. This person refuses, he will not add it. So let me quickly make space for this. So if a miner is honest and he includes only true transactions, everybody will have, most people will add it, and then they can build the next block on top of it. But if this miner is dishonest and brings a transaction that is false, everybody will reject it and everybody will not add the block to their system. If everybody rejects it, nobody will add it to their system. So what does that mean? It means that the money this person is meant to make, the money this miner is meant to make from the fact that they suggested a block, they will not make it because nobody added it to their block. That is exactly what proof of work means. If you want to be dishonest, you want to be a miner, you are dishonest, and you send out false blocks so that you can make money, you approve false transactions so you can make money, it's going to backfire because nobody is going to add it to their block. Nobody will add it. It means so after you, and remember, to mine, you have to use large computing power. You have to set up computers that consume a lot of energy, a lot of time to solve the math equation. That costs money. So after solving all these things and resources, and you broadcast it and nobody adds it, you lose the money that you used to do the solving or the computing. So normally, because of the proof of work, because of the cost of doing the work, most miners don't do any false stuff, the central stuff. So that's basically how it works. If let's say peradventure, let's say this person adds it, this person adds it, others does not add it. Let's say they are working together. They are working together. Let's say they know what they are doing. They are all false validators and stuff. These ones will not add it here. The next one they want to do, the next time they will want to propose a block. Let's say this person now proposes a block. This person is the next miner that gets the ability or gets the chance to propose a block. Remember we said something about hash. Hash links to the old block and the new block. So if this person proposes a new block, the hash here is going to show that, okay, well, I'm still in the previous one. Remember what I said. If this person is to propose a block, a new block, his own hash is going to point to this new block he added, the false block. But if another miner is to suggest a block, his own hash is going to propose to the previous block he's working on. And if he sends this stuff and it gets approved, it means that every single person, every single true block that said no the first time will have this new chain. And that's how it will keep going. Let me quickly distinguish something. I'm coming for better understanding. Okay. So let's say this old block, the false block was added to these ones. Just these three. Now let's say the others are actually honest with their dealings. Remember, this is a meme pool. Don't forget. So now if a new block, what happens to those that did not add this false block to their chain? If this person proposes a new block, let's say he solves it and he proposes a new block, this hash here is going to point to this particular block here, which is this one. His own hash is going to point to all the second block. You understand? Not this false block, because obviously he didn't add it to his chain. So when he broadcasts this to everybody, the ones that maintain the true, that were not deceptive, will not add it to, if they check it, they will not add it to their own chain. So you can see that already we already have this particular set of nodes have this particular block. The old ones choose to add the false block. How do we now know? How do we now know which one? Or somebody can say that, okay, yeah, this blockchain is now being diversified. No, it's not diversified. Let's say we have a new, remember we said nodes can arrive at any time. We have a new node here. We have a new node here. And this new node is a miner. Or let me not even go to a new node. Let's not complicate it. If we do another, let's say this person is also a miner. If we do another, if this person is to suggest, sorry, looking for the best way to explain what I understand. So because we have multiple what's it called? Okay, let's say this person is a miner. If we do another round and let's say this new person wins, we have a suggested block by this person with a hash. Now this person's hash is going to point to these ones. So if this gets broadcasted to everybody, this person now receives this block. This block says this hash is pointing to a pink block. He will check his own. It's not there. He cannot add it to his. So it means that these people that chose this false block here, people that chose this false block here, their own node has been, how do I put it? They have been abandoned. They have lost the true chain. Do you understand what I'm saying? So if this person now, if everybody now adds this yellow block to their own block, that's the honest block, it means that these ones that added that false block, they have lost the chain. Because the new chain now, the consistent chain is after white you have pink, after pink we have yellow. But these ones, they cannot add yellow because yellow is pointing to pink. That's what the importance of this hash is. The hash basically is just like an ID. Let's say we have 4 blocks. This block has ID 1, 2, 3, 4. Obviously, if you see block 2, you know the next block after it is block 3. And the block before it is block 1. That's basically what a hash is. You can't add block, let's say block 11 here. It's not happening because the previous block is not 10. So that's basically how it works. And the reason why this, somebody can say, okay, what if is only the false blocks that are the ones. This is becoming very messy. Let me just clean up a little bit. Somebody can say, okay, what if it's just the false block that keeps suggesting the same? It cannot be possible because every time there is always a new block, there is always a new node. So different nodes will have the capacity to keep suggesting, and if most of them are true, the chain will remain true. Even if they are false block, this particular block, if it is false and this one is false, they cannot be false in the same way. They will have different chains. So the only chain that will be maintained is the true chain. That is how the proof of work works. So the issue, the proof of work, basically what it does is it makes it so that if you lie or you are false with your dealings, then your block, the block you suggested, will not be added, and they only follow the true chain. This is the one that will be maintained. These ones will be forgotten, and you will not make your money. You will waste the money you used to. Let's say you use a computer. Obviously, you need energy to power that computer to solve the math. That's basically how proof of work works. Is basically it. So now let me just briefly talk about how these people make their money, how miners make their money before the end of this video. So let's say So let's say we have, remember we said they will compile a block. This block is a record of transactions. It's just, this is just like, okay, send to, it's just like a record of transactions. I don't go into detail. Then they will seal it. They will seal it with a hash. This hash points to the next and the previous. How do they now make money? You've probably heard of the word gas fees. The money you add to make a transaction. That time we want to send, we said send 5 BTC from OX224 to OX442. You add a gas fee, let's say $10. This $10 now is going to this miner. Understand? So all the transactions they added to their block, if they add, let's say, 50 transactions or 100 transactions, all the money, all the gas fees, their own. Remember we said something about, if you remember, we said something about having a meme pool. Every miner works with the transactions in their meme pool. They can have over 10,000 transactions in their meme pool. So how do they now select the one that they will add to the block that is suggested? That is where people now, it's just like bribe. They will insert, they will try to make their transactions enter the block faster by increasing the gas fee. Let's say we have this person sending this transaction with $10, and we have another person. Let's say this is the miner's meme pool. He has a record of this particular transaction here. Okay, let me use white to depict it. He has this record here, and there's another person here that is sending this same stuff, but is adding a fee of $90 here. So when this and there are obviously other transactions with different gas fee. So when this miner wants to compile this his own meme pool to a block, he will obviously add this person's own first because this person has a higher gas fee. That is why if you want your transactions to go faster in the blockchain, you use a higher gas fee. It's as simple as ABC. They will favor higher gas fees more because they are making money. Nobody cares about you. The miner just wants to make money. He's into the business. He bought those systems, so he just wants to make money. That is one way the miner makes money. The second way the miner makes money is something called the first block, the first slot for record. This particular slot, the miner writes a transactions for himself, a transaction for himself. He can write send to amount to wallet. That's his own. He will add his own money here. In simple terms, not very technical terms. So this first space is for him. He will add his own money. So there's a particular, I think there's a particular range. I think it's 3.14 BTC, and they're allowed to write something like that. Now there's something called, you would have heard the word halving. Let's say Bitcoin is halving. Maybe halving. It's basically like this money that they can add. They are dividing it. They are slashing it. So it's making it more scarce. So that's basically how everything works.